send the signal. You can send the signal by pressing some key combination on the keyboard. So for example, when you press a Control C, right, combination, a process gets a signal. The process which is running currently on the terminal window, and you press a Control C, then the process gets a signal. Okay, and that signal is what we call SIGINT. So SIGINT is the signal which is received by a process when the process is running on the terminal window and you press a Control C combination.
Sir,
Okay?
are you sharing a presentation? Like we are not.
Am I sharing?
Yeah, the screen is not visible, sir.
Screen is not visible. Okay, so I guess I also took a long break. All right. Let me see. Are you able to see my screen now?
Yes, sir.
Yes. Okay. All right. Sorry about that. Okay. So SIGINT, this particular signal is what is sent to the process when you press a Control C key combination on the keyboard. Okay. And the default action for this signal is to terminate the process. Okay. So when you press Control C on the keyboard, that is what will happen. When you press Control Z on the keyboard, you are putting the process in the sleep mode. So you see that SIG TSTP, this is the signal that is sent, 20 number, and for that the process will be basically, sorry, I think the process will be put in the sleep mode when you press the Control Z button. Okay. So what I'm trying to say is that depending on what keys you pressed, the specific signal will be sent to the process, or operating system can send a signal to the process, right, depending on some event, right, or one process can send signal to another process. So signal can be sent by these three different ways. Okay. There is a command called kill that you can issue from the terminal window to send a signal, right? To send a signal to a given process ID. So there is a process ID here, and then you can provide the signal number. Which you want to send to that particular process. If you want to know the list of signals that are available in the system, one option obviously is to look at the header file, but the second option is to use this -L switch. So when you use the kill command with -L switch, it will tell you all the signals that are available currently in your system. So these are all the signals that I can issue, right? So there are total 64 signals that are available in my system. Okay, and some of which we will definitely look at it, right? So SIG kill is there, SIG alarm is there, SIG stop is there. So all of these signals we will take a look at it. SIG continue is there, SIG pipe is there, right? All of these signals we will take a look at it. Okay, now,
Sir,
yes.
Sir, 32, 33 are not there.
32,
Means
33 are?
In those 64 signals?
32, 33 are, there it is, SIG power, SIG sys. So they'll be there. Maybe the number might be a little bit different in the system than what I have provided in the table, but the signals will be there. So even if you look at your system, you will be
able to ordering. After 31, it goes directly to 34.
Right. So basically, what happens is that some signals are reserved by the operating system. Maybe user is not allowed to send it. Right. So kill is the command that will allow you to send a signal to a process, and possibly you cannot use these numbers 32, 33 to send the signal to a process. It is kept as a reserved number for some specific event. Right. So that could, that is probably the reason you are not actually seeing in the kill list, because kill command cannot actually send that signal. That's why. Right. So for example, like I would say, if you look at this particular one, like stop one, This is generally used by operating system for context switching. So we are generally not allowed to use this signal number for sending it manually, something like that. Okay. Okay. Now, when the signal is sent to the process, how are the signals handled, right? So actually delete this background image thing. Sorry. Okay, I'll do it later. So the basic idea is that you have the signal which is sent to the process, and now operating system needs to handle that signal, right? So there's a function that is there in the operating system which is called do signal, which is part of the kernel. So as soon as this signal has to be raised and has to be sent to the process, or when it is sent to the process, this particular function will get executed. So this function first will check whether the default action or the action for the signal is ignoring the signal or not, right? If the action is ignoring the signal, then yes, there is nothing to be done and you're done. Okay. If the action is not to ignore the signal, then it will check whether the default action for the signal needs to be executed. Meaning the default action could be either quitting, right, or maybe doing the code dump, right, something like that. So what is the action that we need to execute as part of the default action? So is the default action needs to be executed or not? If the default action needs to be executed, then it will execute the default action, and then that's it, right? But then you could also have a customized signal handling. So I'll show you later on in the subsequent slide that you can actually create your own function in your code, and you can say that this is the handling, or this is the signal handler for this particular signal. Okay, so whenever a process gets a signal, that is the function I want to execute, and that is a specialized or customized function that you have dedicated for the signal handling for that particular signal. So then the operating system will check that if the default action is not set, but then there is a customized handler is set, then it will execute the customized handler. Now, one thing I want to highlight, or reiterate several times, there are two signals. Okay, there are two signals, sig kill and sig stop. These two signals you cannot override, meaning whatever is the default action for these two signals are there, they will have to be only default action. You cannot change or you cannot override the default action of these two signals by anything else. Why? The reason is being, for example, your process is hung, right? Your process is hung and you definitely want to kill your process, right? Because there is no other way that you can, you can stop that process. So the forceful killing of the process is done using this sig kill signal. So sig kill signal is number 9, I believe, right? So sig kill is the number 9 signal. This is the signal which is always used to kill a process when it is hung, right? So therefore, operating system says that this signal cannot be overridden, or it cannot say, you cannot ignore this signal. Whenever this signal is sent to the process must be terminated. Okay, so this is one signal that you cannot avoid or ignore or change the default handling. Second signal is the sig stop. Why this one? Because this signal is used for context switching by the operating system. So whenever it is used for the context switching by the operating system, you cannot override that signal or you cannot ignore that signal. So the process must take whatever the default action is set for this sig stop signal, must, it must execute that action, right? So these two signals cannot be ignored, cannot be overridden. All the other signals that we have can be ignored and can be overridden. Okay, so you can trap a signal. As I said, you can trap a signal, or basically capture the signal, and you can actually change the default handling to your own signal handling. Okay, again we will see that how to do that. So again, when you catch a signal in the kernel mode, which is the operating system. So see, the operating system is always running in the kernel mode, and the user application, right? User program is always running in a user mode. So user mode does not have access to many of the memory and the kernel code that is there in the kernel mode. So when the signal is received, you have the normal program execution that is going on. Then let's assume that the signal was received by the process which is over here. The operating system will change this process from a user mode to a kernel mode, so that it can execute the code which is there in the kernel for that particular signal, right? So then you change the mode from user mode to a kernel mode. You execute this do signal handling and check whether the signal has to be ignored, signal has to be go through the default action. And if it is found that the signal has to be handled by a customized code which is written in the user application, then that code is again actually over here in the user application. So what will happen is that if the customized function has to be executed as a signal handler, then again the mode will have to be changed from kernel mode to user mode. The signal handler function will get executed. The return code will be placed onto the stack. Again, you go back and change to the kernel mode, and then remaining part of the return handling, right? The return value handling will be executed by the operating system. So this is how your handling of the signal works. Okay. So I've talked, I think, theoretically too much. Now I think it's time to look at it practically, how signals work and how things work. So first thing that we will look at is the SIG alarm signal. Okay. So SIG alarm is a signal which is received when the time that you set for an alarm is elapsed, right? So when the time is timed out, that is the time you get the SIG alarm signal. So alarm is the system call or a function that you can set the alarm for the given number of seconds. So you say how many seconds for which you want to set an alarm, and once that time is timed out, right? So that many number of seconds are timed out, then you the process will get this particular alarm. This particular signal. Okay. What is the default action for SIG alarm? The default action for SIG alarm is that you print the alarm clock message, right? So the operating system will be printing this message, and the process will be terminated. That is the default action. Okay. Now, if you already had set alarm once and you again call the alarm function second time, then the new value, new second value will be used. If you provide 0 value as a count, then the pending the alarm which was already set earlier will be cancelled. So if you want to cancel the alarm, you can use 0. If you want to set a new alarm with a new value, then you can use alarm again with the new value. Okay. So this is an example that we will look at it, alarm test. So as I said, the function of the alarm test is to set an alarm, okay, and then when the SIG alarm signal comes, the default action is going to be it will print the alarm clock message, and then the process will terminate. So you can see that here it's a very simple code. We are just setting an alarm for 3 seconds. Okay, then I'm printing this message and then going into the infinite loop here. Why? Because we want to just wait for the alarm to come. That's all, right? The signal to come, and the process needs to basically go through the default action of the SIG alarm signal. Okay. So because there is a infinite loop here, and then the default action is to print the message and to terminate the process, this printf message will never be reached, right? So this particular message will never come, right, and will not be able to print that message ever. So let me test this code. So alarm and then test. So looping forever, and then 3-second pass, and then the alarm clock message is displayed, and then you come out. Right. So even though there is an infinite loop, you can see inside your code what happened was during this infinite loop, the SIG alarm signal came. Right. It was sent to the process by the operating system when these 3 seconds were timed out. Right. So once these 3 seconds were timed out, this process, even though it was in the infinite loop, it was sent the SIG alarm signal, and the SIG alarm signal's default action is to print this message, and then terminate the process. So the process was terminated. So this is how the default action took place for the SIG alarm signal. Now the question is, what if you don't want to allow default action? What if you want to override the default action and do something else? Right? So overriding the default action is done using a system call called signal. So signal system call basically takes 2 parameters. The first one is obviously the signal number for which you want to change the default action. And then the second parameter is a function pointer here, but it can actually take 3 different values. So this is the function pointer, but it can take 3 different values. So the first value is the macro, which is the SIG IGN. So SIG IGN is the macro which is defined by the operating system, and this basically means that ignore the signal. So it is like a dummy function, right? Dummy function without any action that you do, right? So this is sort of like ignoring the signal. So when you set this as an action, even though the alarm will come, or even though signal is sent, it will be ignored. Second action is taking the default action. So let's say, for example, you have actually changed the action to something else. Okay, so the default action maybe was terminate, but then you change that default action to ignore, and now you want to go back to the default action, right? So you can actually use this SIG DFL. So SIG DFL will basically again set the will again set it to the default action. And the third option you have here is to provide the address of the user defined function, right? So address of the user defined function basically will be the function function name which is part of your code. Okay, so this is how you will be able to override the default action that you have on the, I don't know what's happening. Close this guy, close this guy. So again, as I said, SIG kill and SIG stop, you will, even if you use the signal system call for these 2 signals, you will not be able to reprogram, or you will not be able to override. Okay, only all the other ones you will be able to override. Any of the child process will inherit the signal handling that the parent process has. Okay, so the parent process will whatever the parent process has as the signal handling, all of that will be inherited by the child process once you do fork inside the parent process. Okay, so that is something again you should know about. Pause is the function that you can use for infinite amount of waiting rather than putting a sleep. Sleep allows you to wait for a certain number of seconds. Pause allows you to sleep for infinite number of seconds. Okay. So now let us look at how we can actually override this SIG alarm signal. Right. So let's override the SIG alarm signal. So now in this code, in the main function, right? So what we will do, first we will set an alarm for 3 seconds, right? Now, once we set an alarm, we are going to say that before the alarm signal comes, I want to actually change the default handling to this. And what is this? This is nothing but my function. right? So this is my function. Alarm handler is the function that I have in my code, and I'm going to provide the address of that function here. Okay, so what will happen is that I'm overriding the action of SIG alarm signal. Instead of printing that default message of SIG alarm and then terminate the process, I'm saying that execute this function. That is basically what I'm doing. Right? I'm changing the default action. Okay. Now, once I change the default action, I will go into this loop and I will pause. Pause will basically allow me to wait for, as I said, infinite amount of time. Okay. Now you can see that alarm flag is used here, which I'll come to later. For now, you can see that this alarm flag is set to 0. So, which means that this condition is true. It will go inside the loop and the process will go into the pause mode. Once the process goes into the pause mode, after 3 seconds of timeout, the SIG alarm signal will come. But when the SIG alarm signal will come, it will actually execute this particular function, which means it will go into this function. Okay. So when it goes into this function, it is going to print this message, right? And let me just comment this line out. These two lines out, and let me set this flag. Okay. So what will happen is that inside the SIG alarm handler, it's going to print this message and it's going to set this flag. So once it comes out of this SIG alarm handler, and again it goes back into this while loop, right? So it goes back into this while loop and it checks for this flag. Once it checks for the flag is now 1, which means the condition is false, and so therefore the process will come out here. It will print this message and the process will be ended. Okay, so the default action of termination is not happening here. What is happening? It is going to execute this function. It's going to print this message. It's going to set a flag, and that flag is going to be checked over here, and therefore now the process will end because this while loop condition will be false and this printf message will be printed. So this is how this particular process will get executed. So GCC and then alarm override dot c minus o alarm override dot out. Okay. Right, so waiting for 3 seconds. Okay, so now you can see that this message came from the signal handler, which we have implemented here, right? And then the alarm flag was set to 1, therefore it went back here. The condition now is false in the while loop, and therefore this printf is coming, which is over here. Okay, and once it falls off the last statement, obviously, then your process is ended. Okay. Now, what I want to show you is that you can see that we have actually changed the default action by using the signal handling. But I want to show you that we can actually save the default action and we can restore the default action, or we can save one action and restore the same action again when the next time the same next time when the same signal arrives. So what we have done is we have actually used this old handler. As you can see, it is defined here. It is also a function pointer. It is a variable that is declared as a function pointer. Okay, this is a variable declared as a function pointer, and what I'm going to do is whatever the return value is from the signal. What is the return value from the signal function? The return value from the signal function is the previous function that was associated with that particular signal. Okay, so previous function again could be any one of these three. It could be the signal IGN if the default action, or if the earlier action was sig IGN, then it could be this one. It could be the default action, or it could be the address of the user function, right? So in our code, if I store the previous action, the previous action here will be actually the default action. So it will actually save that default action in my old handler. And now what I'm going to do is, instead of setting this flag, I'm actually going to set the alarm signal again. Okay, I'm going to set the alarm signal again in my handler. But now this time I'm actually not going, I don't want to execute this handler function. I want to again go back to the old default action. So whatever the old action that was saved here, I'm actually using that to again set the that action for the alarm signal. So inside my signal handler, I'm actually setting again back to the default action, and I'm setting a new signal, new alarm, so that again this alarm signal will be sent. But when it is sent second time, right, when it is sent second time, instead of executing this function code, it is going to go back to the default action, because that is what I have set here. Okay, so I want you to show in this example that you can actually save the older or previous action into the variable, and you can use that variable again to go back to that action. That is what I want to show you. So let us go and execute this code. So I'll have to recompile. And now, so first 3 seconds, right? So now this message comes, now second 3 seconds, and you can see that default action happened, right? So in the first 3 seconds, the normal signal, our old signal handler was executed, but then I changed back to the old handler, which is the default handler, and then after the next 3 seconds, the default handling was executed, which is again to print the alarm clock and terminate the process. And therefore, this particular printf was never reached, right? Because what happened was that it was again I didn't set the flag, so this condition was true even the second time, and the process went into the pause mode. While it was in the pause mode, second time this alarm signal came, and so the default action was executed, which is again to print the alarm clock message and terminate the process. So therefore, this printf was never reached. Okay. If you don't want to save the old value, and if you know that second time you want to always go back to the default handling, then you can actually use this also. You can also do this, sigdfl. So sigdfl means again go back to the default handler. So you don't have to actually save this, but you can directly use this one. Okay. So even when I compile this one and run it, it will basically do the same thing, exact same thing. Right? So same output. The only difference was that, what we did in this case is that we actually set the action to be sigdfl instead of that sigdfl was stored in the old handler in the previous case. Okay, so that is what we have done. Any questions for this example? Again, it's very important example for you to understand, because it again covers some of the important concepts for signal handling, the default handler, the ignoring of the signal or overriding of the signal and all that, right? Ignoring of the signal I'll actually cover in the next one, or next example. But this particular example shows you how to override the default action and then go back to the default action. Any questions? Okay.
Hello, sir.
Yeah.
Sir, in the handler, that we were using before, which was not the old handler, there how we were waiting for 3 seconds, because there was no code for waiting 3 seconds in this handler.
Here it is.
Means when this was commented, then also we were waiting for 3 seconds before the message was printed.
No, then we were not actually waiting for 3 seconds. We were just doing this alarm flag. So second time the alarm was not even set. This was the previous code we had. In
Yes,
that
sir.
case, the alarm was only set one time.
Okay, sir. Means there also means initially 3 seconds we were
Yes,
waiting
yeah,
and then
yeah. This one,
okay.
no?
Yes, sir. So okay. So here the default action will be
Correct,
um,
correct, correct. So for this alarm, the default action will be taken care, right? No, for this alarm, this action will be taken care, not the default one. See, I've changed, right? I've changed the default action to executing this function. It's not going to be the default action. So I'm setting the alarm and then I'm saying that the action has to be this one, which is the function. So it will come over here, it will execute this line, it will set the flag. Now this function is completed, right? So this function is completed, so it will go back into the main process. The main process again will start executing from this while loop, and now this flag is set inside the alarm handler. So therefore this condition is false, and therefore it will not go into the pause, but it will do the printing of this one.
okay. Here we were not waiting for 3 seconds. So it was just a coincidence that it took exactly 3 seconds to print that message.
It will not take 3 seconds to print the second time. I think you should try executing this code on your own, so that you understand it better.
Okay,
We are just waiting for one time, 3 seconds, which is this alarm here. Only one time, not two times.
okay, sir.
Okay? Okay. Now what we are going to talk about is how to completely ignore the signal. Right? So in this example, we showed how to override the signal using our own function and our own function, and we also looked at how to go back to the default handling, right? By using seek_dfl. Now let us say that there is a process, and for certain duration, you want to ignore the Control-C keyboard combination, right? What is the Control-C keyboard combination? The Control-C keyboard combination will kill the process. Why it will kill the process? Because it sends the int signal, right? It sends the int. Yes. Can you put yourself on mute? Okay. So what I was saying is that when you press a Control-C keyboard combination, it sends a SIGINT signal, and the default action for the SIGINT is to kill or terminate the process. Okay, but what we want to do is that, let's say maybe there is some important code that is getting executed inside your process, and you don't want the user to kill the process while that particular part of the code is running. Okay, so what you can do is you can actually ignore the SIGINT signal during that time frame. So here we have just used a simple example where we are saying that during the first 3 seconds, the process will accept a Control-C key combination and the process will be terminated. Then we will go and override the default action for the SIGINT signal, and we will say that ignore the signal, right? Ignore the signal. And during this time, which is the second phase of the 3 seconds, right? So seconds 1 to 3, we can accept the Control-C and the process will be terminated. Seconds 4, 5, and 6, Control-C combination can be pressed, but it will be ignored, meaning that SIGINT signal will be sent to the process, but the process will not do anything, right? It will not terminate. And again, we go back to the old handling, which is the default handling, where again the process can be terminated using the control C combination. So basically seconds 1, 2, 3, process can be terminated. Process 4, 5, 6, seconds 4, 5, 6, process cannot be terminated, and process 7, 8, 9, process can be terminated. Okay, so that is what we are expecting this program to do. This program to do, right? So control C override, and now during the first 3 seconds I will press control C first, right? So I do control C, and you can see that now the process is terminated. Okay, because in the first 3 seconds I did not ignore the signal. Now I will wait for that 3 seconds to time out, and then I will press the control C in the second phase of the 3 seconds. Now if I keep on pressing control C, you can see nothing is happening, right? So these many times I press control C, nothing happened because the control C is very ignored at that time. Okay, and then in the last 3 seconds I didn't do anything, I just let that 3 second pass. So the process continued, and the last by was printed, which is this last printf statement. But now what I am going to do, second time when I run, I'm going to press control C in this third phase of 3 seconds, which is seconds 7, 8, 9, right? So during those seconds I'll be pressing the control C, and therefore again the process will get terminated. So you can see that again I press control C right after that message was printed, which must be around 7 or 8 seconds in the process, and therefore there is no by printed, but the process is terminated. So what I'm trying to say is that you can actually have your process, critical code in the process can be saved for, from terminating the process, right? I mean, you can ignore the control C signal or control C keyboard combination and say that, okay, I will not let the process terminate until this critical section of the code is finished. So that is something that you can do. So you could actually create a function here in the code, and you can actually do this ignoring the signal and going back to the old handler in that function also, right? So which is not what I've done, but basically essentially in essence we are doing the same thing. Okay, does that make sense?
Yes, sir.
Okay. Now what we are going to do is that, when you press a control C keyboard combination, or when you send a signal, right, using a kill command, or operating system sends a signal, the question is, we don't have a single process. We have many processes running in this system, and it is possible that the process that you're running on the terminal window does have child processes, because see, remember we have learned process management, and we know that the parent process can actually create many child processes, right, using fork command. So now what will happen if the control C keyboard combination is pressed when the parent process is running, right? So if the parent process is running, should the parent process get that only SIGINT signal, and only the parent process should be killed, or even the child processes should be killed? How these things should work, right? So again, implementing all of these has to be thought about by the programmer who is writing the operating system kernel code, right? Let me go to the picture. Actually, the picture actually will give you more information, and all the other text slides are basically just going to talk about what I'm going to explain through this picture. Okay, so this diagram is going to tell you more about it, and then the same thing is written in those text slides, so you can actually read the text slides later on, but I'm just going to explain using this particular slide. So what happens when you actually run when you run a program, when you run an application on this terminal window, right? So when you run an application on the terminal window, right, there is something called as process group. Okay, what is a process group? The process group is the number which says that how many processes are running under this one particular group, right? So for example, when you have one parent process which has a group number, and then let's say that parent process creates multiple child processes. So each of the child processes will have a different process ID, but they all will have the same group ID as the parent process. So for example, let's say this is the process that you are running on a terminal window, and that is why it is called a foreground process. So foreground process are the processes which runs under terminal window, right? So let us assume that the process with the ID 20 you are running, and that process has created two child processes using fork. So each of these child processes will have the different PID values, but the PGID, which is the process group ID, right? So the process group ID will be the same for all these. Okay, what does that mean? It means that when you press a Control C keyboard combination, and when the SIGINT signal is sent, the SIGINT signal is not sent to a particular process ID. It is actually sent to all the processes which are in the same process group of the foreground process. Which means that when you press the Control C keyboard combination, SIGINT signal will be killing not only the foreground process which is running on the keyboard on the terminal window, but it will also kill all the child processes that are forked using the parent process. So process groups are basically used to manage which process will get a signal when a signal is issued to the foreground or the parent process. Okay, now let us say that you started your program, your application in the terminal window, and we have also said that this particular process, when it starts off, it is basically a child process for this terminal window bash, right? So the shell which is running as a terminal window, this process becomes the child process of that terminal window. But now, if this is the child process for the terminal window process, the shell process, and they both have the same process group, then what will happen is, if I kill this particular process using the Control C combination, even my terminal window will be killed, because both has the same process group ID. So therefore, what operating system does, it uses the shell, which is the main shell, your terminal window shell, in a different process group. Okay, so what it will do is it will fork a child process, obviously, which is your a dummy shell that it will create. So from this shell, it will actually create a dummy shell. Okay, background shell, or a shell window which is not actually displaying anything, which is not there on the terminal. Okay, and it will put that into a different process group, and your foreground process will be running under that dummy shell. Okay, so you can see that your terminal window shell has a different process group ID, and your process which is actually running in that terminal window has a different process group ID. So what will happen is, when you press a Control C keyboard combination, this process will get the SIGINT signal, and these processes will get SIGINT signal because all of them belong to the same process group ID. However, the original terminal window will not get a SIGINT signal to terminate the process. Clear to everyone? Any confusion here? Okay, now the question is, we are pressing the Control C keyboard combination on the terminal window. Okay, so if you are pressing it on the terminal window, how is it that my original terminal window process is not getting the signal? Because the Control C combination is actually pressed on the same terminal window where we started running this process. So to basically handle that, there is a concept called control terminal. Okay, so we have seen the concept of process group, but there is a concept of control terminal. What is the concept of control terminal? Control terminal basically says that which process has a control over the standard terminal devices, standard input, standard output, and standard error, specifically standard input, right? So which process has a control over the terminal, which is your standard input, standard output, standard error for for this particular terminal window which we have, right? So what happens is that when the when this shell creates a dummy shell here, and before this foreground process starts executing in this dummy shell in a different process group, what this dummy shell will do, it will change the group ID to a new group ID, obviously, and then it will execute this particular system call. It's called TC set PG group. So basically each terminal window has process group ID which is controlling that terminal window. So TC basically stands for terminal control, right? So who is controlling this particular terminal? So what this dummy shell will do, it will execute this system call and it will provide the standard input, standard output, and standard error file descriptor, and it will also provide the process group ID. So in short, what I'm trying to say is that once this dummy shell is created here, it will actually execute that system call and it will set all the standard input, error, and output file descriptor process group ID to 20. Okay, it means that process group ID 20 is now controlling that particular terminal window. And so whenever you have a scanf in your program, that scanf will be able to read the data from that terminal window. If the control terminal does not have this particular process group ID, and if the process is trying to read the data from the keyboard, then it will get another signal which is called SIGTTIN, which I'll come to later. Okay, but just to keep in mind that this, once this dummy shell is created, it takes control over the terminal, and once these processes are done running, right? I mean, once these processes are terminated, then this dummy shell will again transfer the control back to the original shell. So basically, this shell again will start, will again run that system call, and it will take the control of the devices, standard devices. Okay, so this is how the control between the keyboard and display is transferred between the original shell and the dummy shell, which is running the foreground process. Now the background process is slightly different. Why? Because the background process does not actually run in the main terminal window. It runs in the background mode, right? So as soon as you run the background process, the terminal window is released. And so the background process does not have access to the terminal window. So you can see that background process always runs in a different group ID than the original shell. Okay, so again, the background processes will have different group ID. The foreground processes and the respective child processes will run in the different process group ID with the dummy shell here, and your original terminal window has a different process group ID. So this is how the access to the terminal window is maintained, and access to the different signals, right, is maintained. So what I'm going to do is, without talking too much now, I'm just going to show you a couple of examples which will actually hopefully make things clear for you. So first we are going to look at a background process. Okay, so what we do is that this is our normal code, right? So we have this signal called SIGTTIN, And as I mentioned, this signal is sent to the process when a process does not have access to the control terminal. Okay, when it does not have access to the control terminal, that means user cannot read inputs from the keyboard, the standard input, right? So I've done this scanf here, and this process, this program that I have, we will run it in the background mode. How do you run the process in the background mode? Using ampersand sign, and sign. So after providing the program name, if you do and sign, the process will start running in the background mode, and the terminal window will be again coming back, to the terminal window outside, because you can now enter another command, right? So anyway, this is the handler for SIGTTIN, and so I'm basically just displaying this message. Once I display this message, we go back to the default handling. Default handling is ignore the signal, okay? But I'm going to override that signal so that we can actually display the message, okay? So let me run that process group background out, and I'm going to run this in a background mode, as I said. Okay, so I do and sign at the end so that the process runs in the background. And now you will see that I'm back to the terminal window, but the process will be still running because the process is running in the background. Okay. Now what happened was, as soon as it ran the main function, it found out that there is a scanf over here and there is a printf over here. And so what happened was, when the scanf was trying to read the data from the standard keyboard, right, standard input, but the standard input device is not accessible by this process. This process does not have access to that device. Why? Because this is a background process. Background process does not have access to the terminal window devices. Okay, so therefore this particular process has received SIGTTIN signal. Okay, SIGTTIN signal, and that is why you can see that this particular message was displayed by the handler. Okay, this message was displayed by the handler, and then the process was put in a sleep mode. So one option to kill the process. Now this process obviously is hung because it is running in the background. It is waiting for keyboard data to come, but I cannot enter the keyboard data because keyboard is not accessible in that process. Keyboard is actually available to my terminal window. Okay, so one option is I can bring the process in the foreground mode instead of background mode using FG command. FG command will allow me to bring the process in the foreground mode, which was the last process placed in the background mode. Okay, so now that process is in the foreground mode and it does have an access to the terminal window and standard input, and I can do Control-C and I can kill the process. The other option is I use the kill command, right? So I run it in the background mode, right? And then I do PS, right? And then I do kill. Kill -9, I can do that, or I can do SIG-kill. SIG-kill will basically kill the process. For that I need the process ID, which is 3312. And so now the process is gone, right? So process is killed. So this is one example where I showed you that the background processes does not have access to the terminal or specifically standard input device. Now I'll show you two more examples where we are going to change the process group of the child process so that we can show that the signal is only sent to the parent process and not to the child process. So to change the process group for the child process, we are going to use this function set PGID, and to read the process group ID for a particular process, we are going to use get PGID function, right? So first what we are going to do is, first we are going to keep the process group same for the parent and the child process. So in this case, I'm actually using the int signal, okay, which is sent when you press Control-C keyboard combination. and I'm going to say that this is the handler I want to execute when the SIGINT signal is sent. Okay, so it's basically going to print this message when the SIGINT signal is sent, and then the process will terminate, right? Because the signal handler is done and the process will terminate, because it will come out of this pause mode and it will terminate over here after falling off from here. Okay, so in this particular example, we are just sending the SIGINT signal using Control C, but when I press single Control C, the SIGINT signal will be sent to both the processes, the parent and the child, because I'm not changing the process group ID. But then when you look at this particular example, this particular example, in this case, I'm actually setting the process group ID for the child process, right? So I'm in the child process and I'm going to change the process group ID, right, to the same as the process ID of the child process. Okay, so this is what I'm going to do for the child process. And so now the child process is running in a different process group. So therefore the SIGINT signal will not be sent to the child process, but will be only sent to the parent process. So anyway, let us first look at this example so that there's no confusion. Okay, so here you can see that the process ID is 3319. Process group ID for the parent process is 3319, right? Child process ID is 3320, and the child group ID, the child process's group ID is 3319. So which means that both the processes belong to the same process group right now, right? However, the process ID is different, right? When I press Control C, you see that I'm getting this message twice, one from the parent and one from the child, because both the process got the SIGINT signal, and therefore both the processes have executed the signal handler, which is basically printing this message. And then both the processes terminate because it falls off from the pause. Okay, so here both processes got SIGINT signal. Okay, now we will run the another code, right? That other code where I show that the child process now has a different process group compared to the parent process, right? Okay, so now you see that the parent process is 3325, the group ID is 3325, child process is 3326, the group ID is 3325 originally, right? Originally it is 3325, and then we changed it to 3326. So now the child process actually belongs to 3326 group ID, whereas the parent process belongs to 3325 group ID, right? And why there are two messages? Because you can see that we are printing first the original group ID, and then we are printing the new group ID over here. So there are two messages coming from the child process. And now when I press Control C on the keyboard, you see that only one process, or only one, which is the parent process, got the SIGINT signal, but not the child process. And you will see that the child process is still running. And the child process is running. It became orphaned because the parent process was killed. So the child process is inherited by the init process. So this child process is running, but it is inherited by the init process. So the only way we can come out of the child process is by killing it, because currently it is in infinite amount of waiting, sleeping, right? So I'm going to kill that process by using sick kill. And the child process is gone. So by changing the group or by playing around with the group IDs, you can actually control which process will get a signal and which will not. There's some more detail to it. which I'll come to that in the next lecture because we are already over time. So that is a kill system call that I will talk about in the next lecture. But if you have any questions about this lecture, I can take them. Any questions? Anyone? Okay. If there are no questions, then let's stop for today. Can we use -A switch to show that hidden signals? Try it out. Try it out. All right. Thanks, everyone.